God, this is so difficult.
Raghav, try this.
What's this?
Mixing frosting is hard. It's physically straining on the wrist and arm. Mixing in food coloring makes the process even worse. Food coloring gets everywhere and stains easily. Most bottles are hard to squeeze for a single drop, and a lot of the dye goes to waste because you cannot open the bottle without making a mess. Even with current tools like hand mixers, stand mixers, or whisks, the process still requires a lot of effort. You end up holding the bowl, the food coloring, and the mixer all at the same time. There are too many moving parts, and it is easy to spill or stain something. To deal with these problems, we created our novel icing mixer. In our model, we included a station for dispensing food coloring. We used powdered dye mixed with water and loaded it into a syringe that is easy to press. This gives precise control and prevents messes. Our design also includes a simple stand mixer setup, so all you have to do is press the power button. No more wrist strain and no more messy bottles of food coloring.
Our first problem was that our 3D modeled pump design was too complex and took way too long to print. So we decided to use a syringe with a spring inside, a simple restoring pump. But no spring had a high enough spring constant to restore the piston in a reasonable time due to suction working against the restoring force. But our Amazon springs turned out to have a lower suction, and thus it worked. For our blade design, we settled on CDs covered with foil because we had a spindle hub which snapped nicely onto our motor axle. But with the motor from Ms. Kumar, no blade design would move real icing, only water. We tried many blade designs, which didn't work. Our solution was to buy a new motor with a greater torque. Our new motor worked great in overhead testing, but we couldn't figure out how to attach it to the blade. Foreshadowing, a lot of the things we tried didn't work.
First, we tried to solder a hole in our existing CD spindle, but it didn't work because we couldn't create the perfect shape, and there wasn't enough friction to keep it spinning on the motor. By now we were going a little crazy, so we decided to smash our old motor to get the thinner axle. And when we did try to solder the thin axle to the thicker one, what happened was all the solder stuck to the bigger motor, because the thinner one was made out of stainless steel with a layer of chromium oxide, which solder doesn't adhere to. We tried to buy a gear attachment, but it was circular and didn't work, so I decided to 3D print a D-shaped adapter to fit it perfectly. After a few failed attempts and help from Zizing, we printed one that works. This was our first working model, and we were so happy that the motor could cut through the icing, but the blade wasn't big enough, so all the icing was pushed to the edge, and the color wouldn't mix properly. To deal with this, we added small bits of CDs to either side of the semicircle to extend the radius.
Alright, first we're going to prepare our food coloring. So first we mixed food grade coloring into water, and we have it in a bowl here. Now we're going to draw it with a syringe. Shake it off a little, then we place it into one of the holes here.
Now we're gonna put the blade on. So I have to match this D part of it to the motor.
Okay, now we're going to put our icing into our bowl. Alright, so right now we have 2 tons of icing in our bowl, and we're going to put a little bit of yellow and see how it mixes. So I'm just going to press on the syringe, dispense yellow food coloring, and then we're going to turn it on by flicking the switch over to this side. So now it's starting to mix. Wow! It's turning green.
Who would have knew?
Wow, sometimes it needs a little bit of encouragement. And that's okay, because we all bode well with positive affirmations. Go, mixer, go. And I love how it doesn't spin so fast that it sprays icing all over me.
Exactly. It's a very soothing process.
Yeah.
It calms the nerves.
We have our frosting in our mixer. Now I'm gonna add a pump of food coloring. So I'm adding blue. All right, our pump is in. Now we turn it on using the switch. All right, it's starting to mix. Wow. All right, it's going well.
Wow, look at that color.
Mm-hmm.
The great part about this is if you want like a marble texture, you can just stop in the middle.
Yeah. You know, some people really are looking for that kind of functionality.
Mm-hmm.
Okay, now we're gonna see how even it is. Wow, it looks pretty even over here. That's very enticing. All right, what about over there? Also pretty even.
Okay, now it's time to eat it. We're just gonna take some over here and put it on our healthy whole wheat bread. Wow, what a color. Okay, let's see it. It's actually so good. The sweet tones of the icing really mixed with the salty whole wheat bread. Wow.
For kinematics, we just found theta, omega, and alpha versus time. And as you can see, omega was pretty much constant. So we tried thickening the icing and we found that alpha kept fluctuating. This is because with each revolution, the blade did not push the same amount of icing, and so that the torque drag was less or more depending on how much icing was there. Our biggest regret was choosing icing because it was so messy and sticky and got everywhere. At one point, we tried to switch to whipped cream, but that did not work out.
Hey!
Just needs a little bit of help, you know?
It just needs a little bit of encouragement.
This encouragement that we predicted actually demonstrates shear thinning. For non-Newtonian fluids, sometimes the initial thickness is very tough, but as the speed increases, the fluid loosens. And this is how we unfortunately convinced ourselves for so long that our bad motor would work. And also, when we tried the whipped cream, it turned into a water consistency at the end, and that's why that didn't work. When the water droplet hit the plastic bowl, it flattened a little on the surface and then splattered. But when it hit the icing, it just completely created a dent in the icing due to the deformation. Also, when this food coloring fell, it fell from such a small height that when we used tracker, it was almost a perfect linear increase in velocity. That means there was no drag force from the falling. Instead, we found a torque drag force in the mixing of the icing by the blade. Due to the viscosity of the icing and resistance within the motor itself, there was a drag torque, and the blade eventually reached a rotational terminal velocity, or a constant omega. In conclusion, this project was a lot more complicated than we thought, but we're glad it finally worked in the end.
Guys, we're good.
Thank you so much for listening, and we hope you like our icing.